Hello Matrix, welcome to yet another video, and we are going to look at another part of physical science for grade 12, okay, which is vertical projectile motion. I took this one from the Free State term 1 exam that was written last year. So let's have a look and see. You are definitely getting a question on vertical projectile motion at the end of this term, so we may as well just put it into practice. Now I told you an object is projected vertically upwards at a velocity of 10 meters per second, okay, from the top of the building, which is 40 meters high. And then we are told here, ignore the effects of air resistance. So if we are ignoring the effects of air resistance, what we are creating is a closed system. Okay, we are creating a closed system. Okay, so only gravitational force is acting here. So now of note, with all vertical projectile motions, you know that our G is taken as minus 9,8 meters per second squared. Minus because I'm choosing up as positive. Okay, so that is always something you need to do when you're dealing with these questions. And then if we're focusing on the trajectory of this ball, we know that this object will reach some maximum height somewhere and then be on the way down. Down to the ground, okay? Don't worry about my wobbly line, okay? So we know that at the maximum height, the velocity there is essentially 0 meters per second. Okay, so we know that at the maximum height, velocity is essentially 0. Is there anything more? At this point, we don't really need too much. We can just work with all that we've got because we were told that this one is 40 meters and it's already indicated. So let's just go to work. Now we're told you define the term projectile in words. Okay, so what is a projectile? Easy. So we've got 4,1. A projectile. What is a projectile? Well, it is an object Philip Bench. An object that is given an initial velocity my E's always try to look silly. Velocity, okay, it is an object that is given an initial velocity, then subsequently experiences only the gravitational force. I'm saying a lot of words here. Throughout its motion. Okay, so easy. It's an object that is given an initial velocity, then subsequently experiences only gravitational force. Alright, so there's an initial velocity given to it, and then it then experiences motion through which gravitational force is the only force acting. So this is how you get those 2 marks, easy. So let's see 4.2. What is the requirement here? 4.2 says calculate the maximum height the object reaches above the ground. Okay, easy. So we know that we can start by doing some calculations. So the final velocity squared is equal to the initial velocity squared plus 2g delta y, isn't it? Yeah, because we want delta y. So this implies now the final velocity, we know that at the maximum height it's 0 squared. The initial was 10. This is 2 into minus 9,8. And then delta y. Okay. Therefore, delta y is equal to, now let's work this out. It's going to be minus 10 squared all over 2 into minus 9,8. Okay, let's quickly do that. Minus 10 squared, which is 100. Divide by 2 into minus 9,8. Okay, so that is 5,10 meters. Okay, but this is just a portion, so we can say therefore maximum height is going to be the height of the building, which is 40 plus the 5,10, which is going to be 45,10 meters. Okay, that's it. All right, so easy. Normally you get a mark for the formula in physics. Correct substitution, you get a mark for that intermediate answer, and you get a final mark. Okay, that is how you score those 4 marks. Next question says the time it takes for the object to hit the ground. Okay, the time it takes for the object to hit the ground. Now, from the instant it has been projected. But now if you're looking at this object obviously starts from here, then it moves to the maximum height and then comes back to more or less the same level. So when the object is back there, it has experienced 0 displacement. So the main displacement here is this one down. Okay, which is nothing but the 40 meters that we already have been given. So the displacement is basically 40 meters down. The initial velocity is that. We don't know the final velocity, but at least we know the displacement. Now we can use a nice formula there. This is 4.2.1. Okay, so we've got 4.2.2. Well, we can use this formula. Delta y is equal to the initial velocity times delta t plus half g delta t squared, isn't it? Because we just want to use this. But now remember that displacement is the opposite direction, so it's going to be minus 40 equals, here is going to be 10 delta t. What am I doing? Plus half into minus 9,8 delta t squared. Okay, this also implies we clean it up a bit. 40 equals 10 delta t. This is going to be minus half of 9,8 is 4,9 delta t squared. Now we can see we have a nice quadratic, which we just transpose things to the one side to have it in standard form. 4,9 delta t squared, we transpose the 10, it becomes minus 10 delta t. Oops, what are you doing? Minus 40 equal to 0. Then once our quadratic is in standard form, we can make a conclusion and say, therefore, delta t is equal to, now we know this is the quadratic formula, so it's going to be minus into minus 10, right? Plus or minus this, plus or minus the square root of minus 10 squared minus 4 into 4,9 into minus 40. Okay, and then all of that over 2 into 4,9. Okay, now let's see what do we get. All right, so minus into minus 10 plus, let's choose the first one as the positive, so we've got minus 10 squared minus 4 into 4,9 into minus 40 divide by 2 into 4,9. So what do we get? I'm getting 4,05 seconds. Okay, now let's check the other one. Usually you don't get both of them making sense for the question at hand, so let's just check the negative. What does it give us? All right, it's giving us a minus 2 comma something, so time cannot be negative. The scalar quantity, unless we've made some errors in our formula, then we may have to do some adjustments, but that is enough. Okay, so what do you do here? Correct formula, correct substitution, and the final answer. Now the question is, where do you get the mark? Do you get it here for the correct substitution? Again, if you've been marked for a correct substitution, you can't get a mark for the same situation. So probably you're getting a mark for expressing that as minus 40 to try and correct for direction. Okay, easy. Now 4.3 says, draw the following set of axes in your answer book. That is what we can see there. Use it to draw the sketch graph, okay, of acceleration versus time to represent the motion of the object from the moment it is projected from the top of the building at t0 until it strikes the ground. So now t1 represents, T1 and T2 represent the times when the object is at its highest position and when it strikes the ground respectively. Okay, that is maximum height, that's when it strikes the ground. Give an indication next to your graph which direction you consider as positive. Okay, we know acceleration is constant, so we're not going to panic. So we've already redrawn this one here, so let's first write, this is 4.3, right? Okay, so we know that we're doing an acceleration versus time graph of the object. Okay, always have a heading for what you are doing, and then acceleration here is in meters per second squared, and then time is in seconds, isn't it? So make sure that is done. Now we chose up as positive, so we've indicated that our choice of the upward direction was positive, so it means acceleration should be a constant but on the negative side. So this is essentially going to be minus 9,8. Why is this 8 trying to look funny? So that is the story right there, okay? Easy stuff, not a problem. So you're getting a mark for the shape and perhaps for those labels. Doesn't really matter. Let's move on to the next question. It says now the object again projected vertically upward from the top of the building as before, okay, at 10 meters per second as before. So that is still the same building. So we can tell that, okay, the height of our building hasn't changed. So we know that we're still looking at 40 meters here. And then of course our object is going to be thrown from the top of the building to some maximum height, and then it's going to come down and reach the ground, okay? Not a problem. Now what are we told? On its way down, the object strikes the top of the window, okay, at a height h, okay, and 3,4 seconds after it has been projected from the top of the building, okay? So not a problem. So I told you, calculate the velocity, the magnitude. Nope, what are you doing? We want the magnitude of the velocity of the object when it strikes the top of the window. All right, not a problem. So we know the initial velocity, it's 10 meters per second. We know the time, we don't know the height, but we can use the simplest of equations here. So 4.4.1, we know that the final velocity is initial velocity plus g delta t. The initial is 10 plus into minus 9,8. The time is 3,4. Okay, so let's sort it out. So this is 10 minus, not minus but plus, into minus 9,8 into 3,4. So I'm getting a minus 23,32 meters per second, which is 23,32 meters per second downward, because we chose up as positive. So we do not disrespect our vectors, even though they want magnitude. We will always think of the direction, because that can be hurtful if you don't get it right. So this is how you get those 3 marks. Last question, we're looking for the height h. Okay, so look, we know that from the same top of the building, okay, maybe let's do it here. From the top of the building, this ball actually gets displaced only that much downward, isn't it? Which we can call delta y. But we know that delta y plus h should give us 40 meters, because I said this is the same building that we dealt with initially. Okay, so let's do this one, 4,4,1. So we want to find out h, but first of all, we know we want delta y. So final velocity, actually we don't need this one. Let's just say delta y is equal to initial velocity delta t plus half g delta t squared, because we know enough. We have 10 into 3,4 plus half into minus 9,8 into 3,4 squared. Okay, not a problem. So what do we know? This is 10 into 3,4 plus 0,5 into minus 9,8 into 3,4 squared. So what I'm getting here is minus 22,644 meters. Okay, so what is that? This is 22,644 meters down, because remember this is the position. Okay, we can say therefore h is going to be equal to 40 minus this 22,644. Okay, so 40 minus 22,644 gives us 17,36 meters. Again, h is just a height, so no need to worry about direction because it is a scalar quantity. All right, formula, substitution, intermediate answer, and the final answer. How many marks? 5. Okay, maybe we can say for this setup as well. That's how you get those 5 marks. Okay, guys, that is the end of our video. Goodbye for now. I'll see you on the next one.